So my name is Prashanth. I am a developer advocate with Google Cloud. As I was introduced, I head a few of the emerging regions for Google Cloud across the world. And here today, I'm going to talk to you about large language models. How many of you have heard of large language models? I hope to see all hands up front. Okay, okay, good. So that means I have something to talk about, right? I don't need to rush this. There are a few folks that don't know about it. Have any of you played with large language models as in tried to use them, use the APIs, use them productively? A few hands. Awesome. Now, this session, I just have 15 minutes in which I have taken 1 minute talking, introducing myself and talking some random stuff. So we just have 13 more minutes. I will spend this time to give you an introduction of large language models, what they are, how they came about, and maybe try to inspire you with some things of how you can actually go take this into production and do things actually with large language models, right? We cannot go into a lot of depth in the time that we have, but hopefully this serves as a little bit of an inspiration and a starting point. The humankind has gone through multiple revolutions, industrial revolutions. We are currently in the 4th revolution, and this is the AI-driven revolution. AI-driven revolution is going to be powered by interactions between humans and technology. And the way this is going to happen is through being able to process and generate human language, right? These are what these AI models are trying to do these days. Now, there's a huge scope for disruption in the industry. A lot of impact is being made in the industry due to this revolution. And what we are especially seeing, which is unprecedented, is that there is a revolution happening in industries other than software, right? It's making a big change in industries other than software. So this is something that we have to watch out for. Large language models have been in the news for the last many months, right? Everyone is talking about it. Almost everyone wants to do something with large language models. And there are a lot of stories about these amazing, mind-boggling use cases and things that people have done with large language models, right? As a technologist, what strikes out the most to me is the sheer massive size of these models, right? One of the large publicly announced models has upwards of 500 billion parameters. To put this into perspective, the previous generation of neural networks and some of the larger models back then, machine learning models back then, were the CNNs or convolutional neural networks. These topped out at about 500 million parameters, right? That is about 500 million. So you can imagine how massive these models are if you are able to poke into them and look at it in this way. With models this size, it's no wonder that we are able to extract so much functionality and capability out of it. But why now? Why is large language models all the rage now? What changed all of a sudden? 3 things happened. One is compute. Massive amounts of inexpensive compute has been made available to the masses. Specialized hardware, that is GPUs and TPUs, which is tensor processing unit, which is specifically designed to do matrix multiplication. These hardware has been made available and is available for the masses right now. There's an unprecedented access to data. Huge amounts of data, massive amounts of texts in digital formats have been made available on the internet that anyone can go and access. We have been able to train models, learn from this information, learn from this human language text that is available out there. And there are a diverse number of data sets. It's not just in a specific domain or a specific concept, but there are huge diverse data sets that we are able to learn from. The third thing is research. There's been an explosion in research in deep learning and related technologies. Further, the researchers have access now to technology, right? The cloud computing has democratized access, where researchers are able to access this technology and are able to develop and build on their learnings, build on the research, build on these models. This has created this perfect environment, right? This has created the perfect environment where we are now able to see these kind of models being developed and actually deployed out into the world. This is a quick look back of how things have evolved, right? So this is how things used to be in the past. On the left side, you will see that this is what we like to call traditional programming, which is rules-based programming. You would train the system, you would train the computer to identify patterns. That's how things worked for a few years, but that is not scalable, right? The real world is a lot more complex, a lot more messy than simple patterns like this. And neural networks started making things a little exciting. What we would do then is you would train the machine to understand patterns in pixels, right? Specifically, if you look at something like image recognition, you would collect multiple images of different things. For example, if you want to train it on to understand what a cat is, you would collect a lot of images of cats and non-cats and get the model to understand, label these images and get the model to understand what these are. And now we are in the world of the generative AI or the large language models. Here what we do is we provide these models with massive amounts of data, textual data, unclassified data. Provide the data to these models, get the models to go through it. And what is very interesting is the model seems to have come up with some sort of a foundational intelligence based on human language. That's the keyword here, right? I'm going to repeat this multiple times. It's based on the text we give it based on human language. It understands how we describe things, how we talk about certain things. And seemingly, it is able to answer. When you poke at these models, right? When you ask questions, when you try to understand what these models can do, seemingly they are able to answer an unlimited number of concepts, unlimited number of questions. So that is what are foundational language models. Now, this revolution, large language models is not really very new, right? It's been in the news for the last few months, but it's been around since 2017. In fact, this is something that was worked on at Google. So the researchers at Google Brain put out a paper on transformers or the transformer architecture in 2017. This was the first paper that came out. Since then, a lot of organizations have built larger and larger language models, but essentially on the transformer architecture. Even in Google, we have over 3,000 researchers across Google and DeepMind, and we have published almost 7,000 papers on related topics. This is the amount of research that is going into this topic. Also, large language models have been powering a lot of Google products for quite a long time now. These models are available on Google Cloud for businesses to use, right? They can use the AI capabilities through some of the products that we have available out there. Also, these power some of the products, Google products that you use today. Translate, image search, Google search, of course, Google Assistant, right? These are some of the products that are being powered by these concepts, being powered by large language models. With that, let's go in a little more detail to understand exactly what these large language models are, how they've come up with. Essentially, these are ML algorithms which fall in the domain of natural language processing, NLP. Right? They can recognize, predict, and generate human languages. These are pre-trained on petabyte scale data, massive amounts of data, and end up being really huge. What is very interesting about these models is that this text is not labeled or, as I said before, right? They are not labeled in any way. So these models are able to understand human language based on this data. Why are they different compared to the other models? There are a few characteristics of large language models that make them very different. First thing are they are characterized by what we call emergent abilities. What this means is that they are able to perform tasks or do things that they have not been necessarily designed for, right? These are things that are, like I said, right? It's not labeled, so they're not included in the training examples, but they're able to do those things when they finish their learning. They're able to understand, it changes the way you interact with large language models is very different. Think of how you would do something like a search before, right? You would have to use the right search terms and be able to extract results from the search engine. Whereas in large language models, when you interact with them, these are like chatbots. You talk to them naturally, you converse with them and extract information from them. So this makes them very different from the other models that you have worked with before. Finally, whereas your traditional natural language processing models, you would tune them or you would train them on specific data sets. It's built for a specific purpose. A large language model is not. It is able to identify patterns and recognize patterns across a disparate data, right? You don't train it for specific, like what we saw in the previous example, recognizing a cat through cat images. Large language models can do a lot more than that. Okay, with that, this is a term that we are using these days, right? So this is what we are calling foundation models. Foundation models is actually a term that was created by the Stanford Institute Center, Human-Centric AI, right? So it's actually a very big name. This is all that I remember of that institute. But they conceptualize this term called foundation models, and this is what we are going to be using right now. Essentially, this is what we discuss, what we describe as large language models. Foundation models are trained on massive amounts of broad unlabeled data. That is what they are. What is interesting are the properties of these foundation models. Foundation models end up being multitask and not single task. This means that it can do multiple things, right? That is beyond what, not trained for a specific purpose. They are generative in nature inherently, which means that they can work with things like text, with images, with audio, with video, with code, and so on, right? They can generate all these kind of formats based on the information that they've learned. Finally, they can work out of the box with minimal training. You're able to start using them and start extracting information from them without doing any additional training on it. These foundation models are what can then be adapted for specific tasks, right? Use them in production. There's some of the things that you actually have to do when you start working with foundation models, when you want to bring them into production and start using them for practical purposes. First thing is something that is called prompt tuning or prompt engineering, right? And this is supposedly one of the hottest fields right now for folks to look at, right? The job market is very interesting in the world of prompt engineering. What prompt engineering means is essentially this is the way in which you are able to extract information or extract output from these large language models, right? By itself, these models don't do anything, but you have to ask them the right questions. You have to prompt them to give you the right answers, and that is an art in itself. Different prompts can yield different results. So the prompt engineers are essentially spending their time to understand how to create the right prompts to extract the results that the model is supposed to be doing. The next thing that we do is fine-tuning. So fine-tuning is a little bit more nuanced. It's more computationally intensive than prompt tuning. Prompt tuning is all about just asking questions to the model. Whereas in fine-tuning, what you're doing is you're training the model on domain-specific data. For example, a generative AI model that will summarize a text, right? And many of you may have tried this example out or seen these examples on the internet, right? You give it a body of text and you ask it to summarize this text. But summarizing any general text or summarizing a text generally is very different from, let's say, summarizing a legal document, right? And giving me a legal understanding of what this document means. In which case, you need to train it with domain-specific data. So that's the next thing that people would do, where you would fine-tune these models on domain-specific data and narrow down its focus to do a specific activity. This is more compute, it needs more compute than what we saw in the prompt tuning. It is less compute intensive than pre-training. Pre-training is what is done to actually build out these models, and it needs this massive specialized hardware, a lot of time, a lot of investment to build out these models. The final thing that we do is called distillation. Distillation is essentially taking this large model and compressing it down to something that you could actually go deploy, which is more efficient when it runs in production. It's a kind of a knowledge transfer. You're transferring the knowledge from what we call the teacher models. So the teacher models are these larger models, the foundation models, and from the teacher models, we create these, what we call the student models, right? Which are smaller, which are more focused, which can do a specific activity that you want to use these models for. Awesome. So with that, just try to give you a little bit of a feeler of what these large language models are, how they came about, what you actually go end up doing with them. There's a lot of things that you can do. This is more of an inspiration. There's a lot more reading that you can do, interact with people in this domain so that you can understand more. And it's something that we have to contribute to moving this research forward, right? Moving this science of large language models, generative AI forward. Some examples of what you can actually do with generative AI that we are seeing out in the industry: making interactions conversational, right? So imagine that you give a more human-like experience to online interactions. So that will really impact the way in which we provide customer service. That is some of the ways that they're being used. Analyzing complex data and making the information intuitively accessible to people. This is the way in which large language models are being used. And also generating content. By just describing what you want, you're able to create content, right? This is something that models can do. These models can be customized with enterprise data or proprietary data to make it more fine-tuned and specific. Awesome. With that, that's all I have time for today. Just want to leave you with a few QRs. Want to learn more about generative AI, this is a place that you can go to and read more. We have, for those who want to be hands-on, we have an online challenge going on. So you can come up to the Google Cloud booth, sign up for these events, compete in it, and win prizes. Finally, that's me, Prashanth. Thank you for being a patient audience. I am KS Prashu almost everywhere on social media. reach out to me if you have any questions or want to talk about things. Thank you.